Alright, so today we're going to talk about VSEPR theory. The VSEPR theory is the valence shell electron pair repulsion theory, which assumes that each atom in a molecule will achieve a particular geometry which minimizes the repulsion between the electrons in the valence shell of that atom. The repulsion leads to this molecular shape. Remember, like charges repel, so electrons want to repel each other. On the next page of your notes, you're going to find a two-sided chart that has all the shapes you're going to need to know. It looks like this. Right? You're going to have to learn what all these molecular shapes are based on the bonded atoms and lone pairs from our Lewis structure. So what I want you to do first is on this chart to draw out the Lewis structures for these three compounds. So pause the video and then draw the Lewis structures. And then we'll talk about how to determine this shape. Alright, so now that you've drawn the Lewis structures, I want you to look at here, we have how many atoms bonded to the central atom? 1, 2. And how many lone pairs? These are the lone pairs on the central atoms. There's 2 of those as well. And so we have 2 lone pairs and 2 atoms bonded to the central atom. And we find that on our chart, just way down here, 2 bonded atoms and 2 lone pairs gives us this bent shape. Right, next we have NH3, which has 1, 2, 3 bonded atoms and 1 lone pair. And we find that shape, 3 bonded atoms, 1 lone pair, is trigonal pyramid, or also trigonal pyramidal. Either is fine. Pyramid is the noun, pyramidal is the adjective. Your xenon difluoride, you should have had 2 bonded atoms and then 1, 2, 3 lone pairs. And 2 bonded atoms and 3 lone pairs will be on the other page. Let's go to the other page. So we have 2 bonded atoms and 3 lone pairs. That actually comes out to a linear shape. And the reason that it becomes linear, you see here, is that the 2 atoms end up getting pushed into a line with those 3 lone pairs, making more of a triangle around the center. And so this one is linear. Okay. Alright, so next I want you to try the next 3. Pause the video, and then come back, and then we'll go over them. Alright, so the valence electrons here, we have 7 times 2 plus 6 gives us 20. Oxygen will go in the center, 2 chlorines around. We give everybody octets. And we count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that's good. We have 1, 2 atoms bonded to the center, and 2 lone pairs. That's just like water, so that's going to be bent. Next, we count up our valence electrons. Arsenic, we have 5 plus 7 times 5 fluorines makes 40. And so arsenic would be in the center, and then we'd have 5 fluorines around, right? And then we fill in our octets. Well, arsenic already has more than 8, so it doesn't need any more. And so we give each of our fluorines 6. And then if we count those, we'll find that we have indeed used 40. And so here we have 5 atoms bonded to the center, no lone pairs. And we look that up on our chart, and we find that is trigonal by pyramid. Okay. And then finally we have sulfur, 6 plus 7 times 4, that's 28, and 6 is 34. And so sulfur go in the center, and the 4 atoms of fluorine will go around, and we'll fill in the octets for fluorine. Sulfur has 8, fluorines all have 8. We count 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 4, 6, 8, 32, but we're supposed to have 34. So those 2 extras go on the center. So we have 4 bonded atoms and 1 lone pair, and that gives us what's called a seesaw shape. Right. Alright, and that concludes this video on VSEPR theory.